Okay, what did we come up with? What makes something be a function? Dan, why don't you tell me? Okay, so I would actually say for every input there's at most one output. There are going to be some inputs that have no outputs on the function, but big key is every input there is at most one output. There could be that there's inputs with no outputs. So when we do inverse trig functions, key to remember that it's a function that one input will only give you at most one output. Now let's make some further observations. The domain, we went through and we listed the domain and range of each of them. If you look at, just breeze back to your notes, we wrote down the domain and the range of inverse sine, of inverse cosine, and today we did inverse tangent. What they all have in common is the domain, your input is a number. For inverse sine and inverse cosine, your input, your domain, is a number between -1 and +1. For inverse tangent, your domain is any number. But with inverse trig functions, you put in a number. And for all of them, the output or the range is an angle. So a big idea is when you do an inverse trig function, your output is always going to be an angle. And since it's a function, it's going to be at most one angle. So when you evaluate an inverse trig function, your answer will always be at most one angle measure. You will never evaluate an inverse trig function and list 2 or 3 answers, because if you're doing that, then you don't understand what a function is. And a function is one input, one output. Okay, so let's try some problems. Let's try this. Okay, so when you do this, when you are asked to find arctan of square root of 3, I want you to understand what this is asking you to do. You're inputting a number. Your output is going to be an angle. So what you're doing, when you're doing arctan of square root of 3, I'm telling you, find what angle I take the tangent of and get that for my answer. So when you're evaluating an inverse trig function, what it's asking you to do is it's asking you to find the angle whose tangent is that. So I'm giving you the tangent value, you give me back the angle. Now, this is really similar to this. That's really similar. This says, tell me what angle I take the tangent of and get square root of 3. And that's what this says. But there's a big difference between them. And the difference is, this you are evaluating a function. You're going to get one output. When you solve an equation, you're coming up with all the possibilities. So this could have many, many, many solutions for x. But when you evaluate a function, one input, one output. So this is telling you to find the one angle, but it has to be in our specific range. Okay, so we're looking for the one special angle in our specific range. So you need to remember what those specific ranges are. My advice for you when you're doing these problems is that you draw triangles and that you put your triangles correctly in the quadrant that they belong in. I noticed when I checked another problem in your homework that was not an inverse trig function but kind of related, that some of you have bad habits of not drawing triangles or drawing triangles not oriented the way they're supposed to be, and your answers are right like maybe a third of the time. Okay, so my suggestion is that you draw a triangle, and when you draw your triangle, you should draw it oriented in the correct quadrant. So to draw a triangle oriented in the correct quadrant, we need to remember arctan gives you out an answer between negative pi over 2 and positive pi over 2. So that would give you an angle somewhere between here and here, not including either of those. Now, since this is a positive number, tangent's positive in the first quadrant, so you're going to draw your triangle in the quadrant that it belongs in. So I'm looking for, what's that one special angle I'm looking for that has that for its tangent? So I can think of tangent as being TOA, opposite, over adjacent. You draw your picture and you say, do you recognize the triangle? Okay, so what's that angle measure right there? Okay, so the answer to this is pi over 3. If you are not given any other directions, you always answer inverse trig problems in radians. So you don't say 60 degrees and pi over 3. You don't say 60 degrees or pi over 3. Your answer is pi over 3. The only time you wouldn't do that is if it says answer in degrees, but that shouldn't happen very often. Now, there are many, many, many angles that have square root of 3 for their tangents. In fact, square root of 3 is like 1.7. You know, this angle has square root of 3 for its tangent. This angle does. This angle does. This angle does. There are an infinite number of angles that have square root of 3 for their tangent, but you're only looking for the one special one. Okay, why don't you try this one, please? Okay, if you did this problem exactly like how I did the last one, this says find the one special angle that has 1 for its cosine. So first of all, you have to decide what quadrant you're in. And you need to know that our cosine or inverse cosine gives you out an angle somewhere in between 0 and pi, including 0 and including pi. So since cosine is positive in the first quadrant, I draw my triangle in the first quadrant, and I think to myself, cosine is adjacent over hypotenuse. So I say, if this is my one special angle, cosine is adjacent over hypotenuse. Then I say, do you recognize that triangle? I don't. So since I don't recognize that triangle, I'm going to find the third side by doing the Pythagorean theorem. I'm solving to find the third side to help me recognize the triangle. I subtract 1 from both sides, and I find out that my third side is actually 0. So if my third side actually is 0, that means to get to this point, I go over 1 and I go up 0. That means I'm really right there. Therefore, the angle measure is 0. No rotation at all. Now, that's probably not how you did it. Am I right? You probably just thought about the unit circle, and that's perfectly fine. But I just want to show you if you happen to draw a triangle incorrectly and do it this way, you would still end up at the right place. So you probably just thought cosine is x and x is 1 only over there, so you just probably just answered 0 that way. Okay, why don't you try this one? Put a little 1 right there, negative 1 there. You don't need to write your negative 1. You just wrote arctan equals. It's like writing square root with and. Nope. Okay, so if I start by drawing my triangle, I just need to know inverse tangent gives me out an angle between here and here, but you can't use either of those. Because remember, the range of inverse tangent is from negative pi over 2 to positive pi over 2, not including. So I want to know what's the one special angle that gives me negative 1 as a tangent value. Tangent's positive up here. Tangent's negative down here, so it's got to be down here. Tangent is TOA, so opposite over adjacent, and one of them needs to be negative, and it's going to be this one because of the way I go over and down. And then you ask, do you recognize the triangle? Yes? How do you recognize it? The legs are the same. If the legs are the same, it's got to be a 45, 45, 90. So therefore, the answer here is, this angle here is 45 degrees. So the answer to this is negative pi over 4. This is a really common answer I get from people. Can you understand what that person's thinking? You could get to that angle by going like that and calling it 7 pi over 4. Now, when you write it this way, one input, you're giving me two outputs. This is wrong. That is not part of the answer. There's only one way to get there, and it's negative pi over 4 because of the way the ranges are written. Do you have any questions so far? Okay, so let's try this one. Okay, this is when drawing your triangle in the right quadrant is really essential. So what this problem says, it says find the cosecant of the inverse tangent of -3/5. Well, first of all, what you find the cosecant of is an angle measure. So what I just scribbled out must be an angle, because the only thing you can find the cosecant of is an angle. So I'm telling you that this is an angle measure. So this says find the one special angle whose tangent is -3/5. So I'm going to draw my triangle, and I'm going to first of all decide what quadrant it's in. So this says find the one special angle whose tangent is -3/5. Tangent gives you output somewhere between -π/2 and +π/2, not including either of those endpoints. And tangent is negative down here, positive up here. So since I'm talking about a negative tangent value, your triangle is drawn in the fourth quadrant. So when this part says find the one special angle whose tangent is -3/5, here's my angle. Tangent is opposite over adjacent. Now, you have to have a negative somewhere, and because of where I drew my triangle, the negative is on the y, not on the x. It's not because the negative is on the 3. It's because the way the triangle is oriented. Okay, so this part says find the one special angle that has -3/5 as its tangent value. So I drew my triangle, and now, see, the question is, do you recognize that triangle? I don't either. So if I had to find that angle measure there, I'd be in trouble if I didn't have a calculator. I can't find that angle measure. But thankfully, that's not really what I want. I don't really want to find the angle measure. I really want to find the cosecant of the angle. Cosecant is the reciprocal of sine. And even though I don't know the angle measure, I can find its sine. Sine is opposite over hypotenuse. So if I just find my hypotenuse will be square root of 34. Therefore, sine will be -3 over square root of 34. Therefore, my cosecant will be that flipped upside down, which is negative square root of 34 over 3. Do you have any questions? Okay, one more. Okay, so this is just a teeny bit more difficult than the top one. because we still have like a function inside of a function. We have our cosine inside a tangent, but a little more difficult because now instead of having a negative 3/5 there, I have an x over 5. So first of all, what quadrant should your triangle be drawn in? Because we're working from the inside out, and is it true that our cosine only gives you out angles in first quadrant? 1 or 2. When would your triangle be in the first quadrant? If this x over 5 is positive. When would your triangle be in the second quadrant? If x over 5 is negative. Did I tell you whether x was positive or negative? What if x was negative 2? You don't know what x is. X is an unknown. Yes. So actually, in order to deal with this, you need to draw a scenario in each quadrant. There are 2 possible ways this could look. Okay, because x is a variable, and I do not know if it's positive or negative. If x is positive, then this cosine value will be positive, and then we have this scenario. If x happened to be a negative number, which it could be, like negative 3/5, x could be negative 3, and then I would be doing our cosine of negative 3/5. And in that case, I would get this scenario right here. So I have to account for both of them. Because since you do not know whether x is positive or negative, you don't know what it looks like. So let's take a look at the first one. In the event that x is a positive number, cosine is adjacent over hypotenuse. I don't recognize the triangle at all. A good thing I don't have to, because I'm just supposed to find the tangent, and tangent is opposite over adjacent. So my answer is going to be blah, blah, blah over x. So I just need to find my third side. And how do I find my third side? How do I find the third side? Okay, if I did the Pythagorean theorem, then I would get x squared plus b squared equals 5 squared. So I'm trying to find what b is. So I get b squared equals 25 minus x squared. And then to solve, I take the square root of both sides. And when you take the square root of both sides, you always get a plus and a minus. Can I simplify this at all? No, that's wrong. You can't break apart square roots when things are added and subtracted. So therefore, using the Pythagorean theorem, my third side is either plus or minus square root of 25 minus x squared. Did you have that? Did you have plus or minus when you did Pythagorean theorem? Okay, so if you did not have 2 triangles, and you did not have the plus or minus, there's 2 mistakes you've made in this one little problem. And they're going to get you. All right, so let's decide which is it, plus or minus. So to decide that, I go back up and I look at the quadrant I'm in. In this quadrant, B would be equivalent to being the y value up there, and y values there are definitely positive. So it just so happens in this case, if you forgot that plus or minus and you just wrote this, you are okay in this case. So in the case where x is positive, your triangle is in fact drawn in the first triangle, or probably in the first quadrant, and tangent will be opposite over adjacent, and there's your answer. And let's see what happens over here in this situation. In this scenario, Then if I set up my triangle, cosine is adjacent over hypotenuse. Adjacent over hypotenuse, if x already is negative, that's what that would look like. My third side would still be this. So therefore, tangent is still opposite over adjacent, so I get the same answer either way. Regardless of the two scenarios, you get the same answer either way. Do you mean in this case?
Yeah.
Or in this case? This one up here?
Yeah.
If you don't draw your triangles and your answers are wrong, you're going to lose all your points. And some of you already experienced that on the last little quiz we had where I had a whole bunch of problems there and I told you to just evaluate, sine of pi over 4, cosine of negative 5 pi over 6, stuff like that. Some of you had no work and had wrong answers, and so you lost all the points for it. Okay, which to me is kind of a harsh punishment for not taking the 3 seconds it takes to draw a triangle. So why would you not draw your triangle? You too busy? Don't have enough lead? No, I'm asking, why would you not draw your triangle? Are you too cool or what? Okay, so here we come down to, I am usually, as a teacher, I'm like, do it whatever way you want to. If you get the right answer, fine. Okay? I want you to draw your triangles. And the reason I do is what's coming next after this and what will come in the future and what's going to happen next year when you have to just remember and pull this stuff out of thin air. It's going to be better if you have that procedure in place. So draw your triangles because I said so. Okay? If you have a mom, you've heard that comment before. Right? Because I said so.
On the bottom problem, why was that being negative?
Because the x is negative. The x already is a negative number, so if you do negative x, you're doing the opposite of a negative number and you're making that side positive, and then it should be in the other quadrant.
What then if it's a negative number to begin with and you're dividing it for 45 minus x squared?
Correct, and in this quadrant, tangent certainly should be negative because this is positive, because your final answer is a tangent value. And square root always gives you out positives, and this is negative, so the tangent value is a positive divided by negative, which is negative, which in fact it should be in this quadrant. So yes, the tangent value is negative. Do you have any other questions about this? Correct. It would not be. If you forgot that, and if you forgot this plus or minus, 2 mistakes, but in this case, they both ended up not being relevant. But I can change this problem a little bit. For example, I could change arc cosine to arc sine, and everything will change. So if I change what functions are here and here, it ends up being hugely important whether you have the plus or minus, and whether you have the plus or minus here, and whether you have the 2 triangles drawn. That's why I showed you how to do it the correct way. The bottom line is when you have an x in there, you do not know the value of x. So you do not know if x is positive or negative. So you have to look at all the possible scenarios. All right, let me tell you what your assignment is and then my plan for the next week or so. Okay, so your assignment for tonight is on page 351. Numbers 30 through 38, 39 through 47 odd, 48, 49, 51, 54, 57, 59, and 73. We're going to talk a teeny bit about section 4.8, but we're not even going to cover an assignment out of the book because I think it's stuff we've kind of touched on already. So we're going to start reviewing for your chapter 4 test. I could squeeze things in and we could test by Thursday. If we had school on Friday, it'd be very comfortable to test on Friday. But I don't really feel like I want to squeeze things in and test on Thursday. So what we're going to do instead is we're going to kind of just start stepping a little bit into Chapter 5. Chapter 5 is more trig, and if I didn't tell you it was a new chapter, you wouldn't even notice, because Section 5.1 is more about simplifying and proving trig expressions. So we'll just start 5.1 and then we'll have your test. So your test will either be on Monday or Tuesday, or Monday and Tuesday, because I have not written it yet, so I don't know if it's going to be a 1 or 2 day test. And if you have a real aversion to Monday tests, then we won't have the test on Monday, but we can talk about that later. How many of you are going to be gone on Thursday for the CIS field trip? No, I think it's just physics. Okay, just Alex, okay. Alrighty, so you have time. You can get started on your homework.